Hello guys and welcome back to Mossy Maths. Today we're going to be going through a new topic called proof, and this is now part of the new 2017 mathematics specification. And this will be 2017 and onwards, and proof is a topic that has many parts to it. In this lesson we'll be focusing on a type of proof called consequence and equivalence, and this involves something called implication statements. Now, the key points are on the left side of the board, and these are the things you need to learn. The things on this side are examples which we will be going through to clarify our understanding on the topic. Now, we'll cover the whole of this topic in one lesson. So to start with, what are implication statements? Well, it's where we say one statement implies another and vice versa. For example, A implies B. And we write this in this way here. A and then an arrow, so it's two lines like an equal sign, then an arrow. A implies B is what this means. We can equally write B implies A, which is just a B in front and then an A second. We could also say B implies A by writing A on the left hand side and B on the right hand side, but reversing the arrow like this. Or we could say A implies B by reversing the arrow and having B on the left side. Now these are things to learn. Learn how we can mathematically write these statements. Now, when we say A implies B, we can also say this in a way that A only if B. And that means exactly the same thing as A implies B. So if you see things written in this way, don't be put off by that. B implies A can be written as A if B. And again, they're things to learn. Now, with this one, A implies B and B implies A, because as you can see the arrow is pointing one way and then pointing back the other way. So A implies B and also B implies A. And this can be written as A if and only if B. So learn those statements. Finally, we're just going to look at something a little bit extra. Now you might not necessarily be needing this right now, but certainly at higher levels of maths, you will look at this when it comes to implication statements and consequence and equivalence. We have a truth table. Now with statement A and statement B, and A implies B. So if A is true and B is true, we can say that A implies B is true. If A is true and B is false, then A implies B is also false. If A is false and B is true, however, A implies B is true. And finally, if A is false and B is false, then A implies B is true. Now that might be weird to think about. If two things are false, how can that mean that A implies B can be true? Well, that's how the truth table works, so it's difficult to justify. The main thing is that you learn this table, so you can easily spot whether something's going to be true or false. But for the start of this lesson, we're just going to look at some example statements. And we're going to try and work out which way the arrow goes. So the first one's actually not very mathematical at all, although the same principles apply. If I say I live in England, we can call this statement A. And if I say I live in Europe, we'll call that statement B. Well, if I live in England, then I do live in Europe, so A implies B. We can draw the arrow this way, okay? Because if I live in England, that implies I'm in Europe. I mean, at least geographically. Let's not get into the politics of everything, but geographically, if I'm in England, then I am in Europe. Can we say that B also implies A? If I live in Europe, does that mean that that implies I live in England? Well, no, it doesn't. Because if I live in Europe, I could live in Spain, France, Italy, Belgium. So the arrow can't go the other way, it has to go that way, okay? The second one, statement A is that x is 4. Statement B is that the square root of x is 2. Which way does the arrow go? Well, if x is 4, does that imply that the square root of x is 2? Well, yes, it does, although it also implies that the square root of x is minus 2, so we can't draw the arrow this way. Because remember, the square root of 4 is also negative 2 as well as it is positive 2. So we have to be careful here. Yes, it does imply that it's 2, but it could also be minus 2, so we can't necessarily draw it this way. Now, if we look at the other statement, can we draw the arrow the other way? Well, we can. Because if the square root of x is 2, then x is 4. That makes sense. Because if the square of 2 is 4. So if the square root of x is 2, it has to be 4. X has to be 4. So the arrow can go this way. Although it can't go the other way because there's actually a negative 2 also. Looking at the third statement, y is a multiple of 2. Does this imply that y is even? Well, we'll call this statement A. And we'll call this statement B. Well, if y is a multiple of 2, it most definitely is even, because that's the definition of an even number, that it has to be divisible by 2. So the arrow can certainly go that way. But then again, if y is even, it also has to be a multiple of 2. It works both ways. So the implication statements in this case follow from each other. We have A if and only if B. So you should get used to being able to not only draw the arrows both ways, but also to be able to say, well, in this case, A if and only if B is how we would write this implication statement. Just to clarify, by the way, when we're talking about consequence, this is where we have something implying something else. Okay? In this case, equivalence, because A implies B and B implies A. So these are examples of consequence as well as this is an equivalence. Okay? Finally, have a go at this one yourselves at home. Pause the video and then I'll go through it with you afterwards. Okay guys, hopefully you've gone through this example at home. X plus 2, x minus 2 is 0, multiplied together. And we have x squared minus 4 is 0. So which way do we draw the sign? Well, let's try expanding the brackets. What we get here is x squared plus 2x minus 2x cancel. Plus 2 and minus 2 gives us minus 4. So expanding this does give us this. So if this is 0, then this is 0. It's the same thing. But like expanding, we can likewise factorise. It's just the reverse. So if we factorise this, we're going to get back to this. Therefore, again, we have an equivalence. Now, to finish off the lesson, we're going to look at something which involves saying whether an implication is true or false. Looking back to this truth table. It's more of a challenge because it's not something that's necessarily going to come up, although it's something worth knowing for higher levels of maths anyway. And it'll only take a few minutes to go through. The statement on the left, A here, says that 4 is less than 2. Well, straight away we know that that's false. So I'm going to write an F there for false. Statement B says 24 plus 2 is 26. That's true. So we'll write true there. So what we have here is false implies true. So statement A is false. So we look here in the table. Statement B is true. So it says here that A implies B is true. So in this case, the answer is true. Now for this one, statement A is that 5 squared is 25. Well, that's true. Statement B actually says that 47 is even, which is false. So here we have statement A is true and statement B is false. Well, if A is true and B is false, then looking at the truth table, A implies B must be false. So that's just an extension to our understanding of consequence and equivalence. That finishes the lesson on this topic. So thanks a lot for watching the video. Hopefully you understood what we went through there. Like I said before, this is something that is relatively straightforward. It's just a case of learning how the arrow system works and being able to learn how we would write this in English. For example, A if and only if B, A if B, and so on. The truth table is something worth knowing because you never know what they might ask in the exam. It's something that could always pop up as an extra mark question. So if you found the video helpful, please leave a like. And if you do have any questions, do feel free to leave a comment and I'll try and get back to you with a response as quickly as I can. So thanks a lot for watching the video and I'll see you in the next lesson on proof.